All right, so an electric drill can be used to drill holes, tighten a screw, or sand a rough surface. To change the function of the drill, you replace or substitute the attachment. So we're going to use this analogy of a drill. If I put this drill bit in, it'll drill a hole. If I put a sander bit on it, it'll sand something. If I put a screwdriver bit on it, it'll screw a screw into the wall. If I use this bit or this bit, it'll actually make a hole in something. So we could change the function of this tool by simply changing or adapting or substituting in a part of it. So a carbon atom in an organic compound has 4 attachments. In a methane molecule, the carbon atom has 4 identical attachments. It's hydrogen atoms. Chlorine atoms can replace hydrogen atoms. And that makes sense because hydrogen atoms has 1 valence electron, right? And chlorine is a group 7. But it can share. That's the versatility of carbon, is that carbon can accept an electron or it can loan an electron. But anyways, you could replace it. So when you look at this, here I have methane, I think, if I remember correctly, and then I can replace one of those atoms with chlorine. Okay. Chloromethane and hydrogen chloride are products of a reaction between methane and chlorine. This is one of your reading guide questions. The other 2 products, or other products, have 2, 3, 4 chlorine atoms. Organic compounds containing chlorine or other halogens are called halocarbons. So halogens are that group 17, right? Just a refresher. So a hydrocarbon in which one or more hydrogen atoms has been replaced by an atom or group of atoms is a substituted hydrocarbon. Again, this is from your reading guide directly. A substituted atom in a group of atoms is called a functional group. So we have a graph here, and basically what they're doing is they're substituting chlorine for one of the hydrogen atoms. Now remember that chlorine has 7 valence electrons and has more protons, so it's a bigger, denser atom than just a hydrogen. And consequently, as I increase the number of chlorine atoms, in other words, if I go from methane to chloromethane to dichloromethane to trichloromethane, remember, di means 2 chlorine, tri means 3 chlorine, tetra means 4 chlorine. I change the boiling point. I need more energy to move that more massive atom. Chlorine weighs way more than hydrogen. So I need more heat to increase the kinetic energy to change the phase. So using graphs, we can make predictions. What's the cause and effect? Well, basically, the higher number of chlorine atoms we put in there, it changes the properties of the substance. Bromine is more massive than chlorine, so we could probably even take from that same group and substitute with bromine. So what would that do? Well, that would change even more because it's more massive. It requires more kinetic energy, and that means it would have to absorb more thermal energy to change a phase. So what functional groups are found in alcohols? Well, it's a negative OH. The functional group in an alcohol is called the hydroxyl group. And so methanol, which is like methane, just happens to have OH replacing one of the hydrogens. So remember that methane is CH4, but methanol is replacing one of the H's with OH. So that's called methanol. Ethanol is a very similar situation. We're substituting OH for one of the hydrogens. And then it's often mixed with gasoline to help it burn more completely. Okay. All alcohols end in OL. Okay. So here's ethene. We talked about that earlier. And then if you add water to it, then that water can be separated and it makes ethanol. Now this is a chemical process, obviously, but ethanol burns a little cleaner because it allows the oxygen and hydrogen to combine with the oxygen and the carbon, so it burns a little cleaner. So they put ethanol in gasoline, which is helpful. Some cars now burn very high levels of ethanol, which is an alcohol. What function groups are found in organic acids and organic bases? Well, the functional group in organic acids is called the carboxyl group. I can't talk today. And that contains carbon, oxygen, and hydrogen. Okay. What functional group is an amine? Is an amino group. Now that's important if you guys remember your biology, amino acids, right? We're talking about acids and bases. That has nitrogen and hydrogen, NH2. All right. So let's look at this. If I go back to methane, which is CH4, and I replace an H with an oxygen, and I replace an H with OH, that's going to give me a different solution. So it's methane, I can't say the word, but it's that acid. Birds sometimes will sit on ants' nest and allow the ant to crawl over them because they have acid that's sprayed by the ants, which is a natural pesticide that kills mites in the bird's feathers. Okay. Do you know that the smell of rotten fish, anybody ever smelled rotten fish? You ever go fishing, you get that smell? Then you've encountered some sort of substituted hydrocarbon called an amine. Amines are organic bases. Amines are found in paints, dyes, and disinfectants. How are esters formed? Well, esters are formed when organic acids react with alcohols. So if I take this chemical reaction and they interact with each other, the esters are a group of substituted hydrocarbons. Esters form when an organic acid reacts with an alcohol. So here we have an organic acid, and it's going to react with an alcohol. And then we have a somewhat, it's not quite equilibrium, but it's a two-way reaction involving hydrogen. And then we get methanol, ethanoate, and water. Or methyl acetate is another way that you could pronounce that. So what are esters? Esters are used in many processed foods to produce fruit flavors. Esters in roses and other flowers have distinct odors and attract insects. And we'll just skip the assessment questions today. Does anybody have any questions on anything? Okay, good.